5.2 is also review. Do you guys remember how to do inverse? Switch the x and the y. Solve for y. Okay, that's your inverse. So f of x stands for y. So if you have f of x, make that a y. Then you switch the x and the y and then solve for y. And then you're going to see if you can solve. Can't solve, there's no inverse. So, for example, we have f of x equals 3x squared minus 6. I'm going to change this to a y, and then we'll switch the x and the y. So this is going to be x equals 3y squared minus 6. Okay, then I'm going to solve. So I'm going to solve for y. I'm going to add 6 to both sides. That's going to give me x plus 6 equals 3y squared. Then I'm going to divide both sides by 3. Okay, then I had x plus 6 over 3 equals y squared. Up over here. And then I'm going to take the square root. Okay, and this is going to give me y equals plus or minus the square root of x plus 6 over 3. And the square root's over the whole thing. Okay, so I can tell just from looking at the equation of this function that the equation does not define y as a function of x. And the reason why is because we're going to go all the way to the bottom here. Right there. Because of the horizontal line test. Okay, so if you can draw a horizontal line through the graph and it touches it more than once, it does not have an inverse, or y does not define function of x. We call it function. It has an inverse. So if it does have an inverse, so it's 1-to-1 or not 1-to-1, basically. Okay, so this is not 1-to-1. That's how we're going to say it. If I can draw a horizontal line and it only touches the graph one time, we say that is a 1-to-1 function. So I'm going to go back up to this example. And right away I knew that because this is a parabola, 3x squared minus 6. So I know that that graph is going to look like this, which means if I draw a horizontal line through this graph, I'm going to hit it more than once. So it is possible to still be able to solve for y, but for your function to not define y as a function of x. Or to not be so confusing in wording, just not 1-to-1 is what we say. Which means that if I switched every single x and y value out on that graph, they would not correspond as they're supposed to, as an inverse is supposed to. That's what that means. Okay, but you can still find the equation of the inverse. You don't just say, oh, I can't do it. You can still find the equation, but you just have to say, is it 1-to-1 or is it not 1-to-1? So let's take a look at example 2. So when I look at this, what kind of graph is that? If I just think about the equation here. Yeah, it's just y equals mx plus b, right? So it's just a line. So if I draw a horizontal line, that's good. So this is a 1-to-1 function. So think about that when you see these equations first, what kind of line is it? And then that will tell you, okay, this is 1-to-1, because you're going to have on some of the homework you'll have that question, like it'll say inverse first, and then at the bottom it'll say like the multiple choice 1-to-1 or not. Okay, so let's take this, let's switch the x and the y, make this a y. So this is going to be x equals 3/4 y plus 7. And then we're going to solve for y. So we're going to subtract a 7 from both sides. We've got x minus 7 equals 3/4 y. How do I get that 3/4 to the other side? Good, yes, reciprocal, so 4/3. You could probably get away with leaving it like that. 4/3 x minus 7. You can multiply it out if you'd like. It's up to you. So if I took this and went, I'd go 4/3 x minus 28/3. And then there's my inverse function. So maybe if I were graphing it, I'd want to do that. Otherwise, you could probably leave it like that and be fine. Okay, so example 3. If -3, 5 is a point on the graph of a 1-to-1 function, f, what is the point that would be on the graph f to the -1? So first of all, this indicates here, that just indicates inverse. Okay, so that's what that means here. And all inverse means, if you're given just a point, is switch the x and the y. So all you're going to do is you're just going to switch this. So if -3, 5 is a point on the graph of a 1-to-1 function f, then on f to the -1, you would have the point 5, -3. So you just switch the x and the y there. And then for example 4, find the inverse of the 1-to-1 function, and then state the domain and range of the inverse function. So you're just switching these. So you'd have the point 16, 8, then 5, 9, 0, 10, 1, 11, and -5, 12. And then the domain, you would just list out the x values. So 16, 5, 0, 1, and -5. And then the range, your y values. So 8, 9, 10, 11, 12. So if I took this and I looked at a graph, okay, and I wanted to find the inverse on the graph, all I'm going to do is I'm going to plot, switch the points. So let's write out our points here. So you have 2, 5. So the next point, you're going to switch that. You're going to want the point 5, 2. So let's go ahead and find that. So 1, 2, 3, 4, 5, 1, 2. So it's going to be right here. Okay, then I've got 1, 2. So I want the point 2, 1. So 1, 2, 1 right here. Then I have -3, 1. So I'm going to switch that. 1, -3. So 1, -1, 2, 3. And then -4, 4 is still -4, 4. So that has the same x and y. Okay, if I connect the dots on this graph, this is what it looks like. There you go. So it is symmetrical. So we're going to say this about inverses. Inverses, or inverse functions, are symmetrical with respect to the line y equals x. Because there's your graph, y equals x, symmetrical about that graph. Okay, and then I think we have a little bit more about inverses. The horizontal line test, which we looked at. And then verifying inverses. So verifying inverses, there's a hard way to do it and there's an easy way to do it. So in the hard way, you're going to have to do f of g of x and g of f of x. And on the homework, there might be like a 3-part problem where it says, what is f of g of x? What is g of f of x? And then are they inverses, yes or no, right? So if it does that, then you have to do it this way. If it doesn't, if it just says yes or no, then you can just find the inverse of one of the functions, and if it's the other one, good. If it's not, they're not inverses. Okay. So if they are inverses though, then f of g of x will equal x, and g of f of x will equal x. So let's do this. So let's do the easy way first. I want to show you this. Okay, so I have f of x is 4x minus 7. So I'm going to go y equals 4x minus 7, and I'm going to find the inverse. So I'm going to say x equals 4y minus 7. So I'm going to solve for y. I'm going to add 7. It's going to give me x plus 7 equals 4y. I'm going to divide by 4. And I'm going to get y equals x plus 7 over 4. And it looks like 9. Okay. Then I'm going to say, well, that is exactly what g of x is. So these are inverses. Which means if I know that they're inverses, then when the question says, what is f of g of x? I could just say it's x, since I know they're inverses. And what is g of f of x? I could also just say that it's x. What do I mean by that? Let's do that. So if I'm going to do f of g of x, I'm going to do f of g of x. F of x, so starting from the outside, is 4x minus 7. I'm taking g of x, and I'm plugging it in right here. So when I do that, I've got 4, and then I've got a parentheses. I'm going to put my g of x in there, and a minus 7. Here's g of x, x plus 7 over 4. So I'm going to plug that in right here. And then I'm going to simplify this. So if I go through and I simplify this function, these 4's cancel out. And then I get x plus 7 minus 7, which also cancels out. And I'm just left with x. So if they are inverses, then that's what you're going to get. And the same thing's going to happen if you do g of f of x. So if I go do g of f of x, okay, I'll start with g of x, which is x plus 7 over 4. I'm going to put f of x in for this x value right here. So that is going to be, let's see, 4x minus 7. Then we're going to do plus 7 over 4. So that went in for this x right here. And then I have negative 7 plus 7 cancels. 4 over 4 cancels. And I'm left with just this x right here. Okay, so you can go through and you can do the composition function and find the x, or this way is much quicker and there's less chance of making a mistake. So that's why I like that way better. But again, up to you. As long as you show your work whichever way you did it, I'm fine with that. That's with something like that. So let's look at example 2. Let's see, are they inverses of each other? So let's just go ahead, let's find the inverse of f of x, see if it matches with g of x. So we've got, let's see, y equals 5x minus 9. X equals 5y minus 9. Switch them. Okay, I'm going to add 9 to both sides. I'm going to get x plus 9 equals 5y. Divide by 5. And I get x plus 9 over 5, which is not g of x. So there we would say that no, they are not inverses. Now, the only thing you might run into is on your homework, you might get a problem where they're not inverses. If I could spell. There we go. You could get a problem where they're not inverses, and then you still have to answer the f of g of x and the g of f of x. In that case, it's just extra practice with composition functions. And I think that's 5.2. Yeah, so I'm going to pause this now. Stop this.